So what we're doing, you need to make sure that you have your yellow exponent rules right next to your packet. Okay, so it should be on day 3. We're going to go back and forth. All right, so the first one is product of a power. That's in your top left corner. Product of a power. What we're doing here is we see that we have a base of A, correct? If we have the same base, that means we look at our exponents and we are going to add them. Okay, if we multiply the same base, we add our exponents. So an example would be p to the third times p to the fourth. Okay, I have the same base of p, so that stays the same, and I add my exponents. So what is my answer? P to the what? P to the 7. Okay, so if you are multiplying the same base, you add your exponents.
We have a test before the quarter ends.
Yeah, you'll have a quiz. Okay. Another example is you may have fractions. Okay. If we have fractions for exponents, do you notice how we have the same base of W? That stays the same. And then I have 1/4 that I'm going to add to 2/4. So what is my answer here? W to the what? To the 3/4. Same concept, it's just now we use the fraction. Okay? You all need to keep up with this yellow paper because I will let you use it on your test. Okay? These things are lifesavers. This is just one part. Excuse me, what? We just added your fractions together.
So basically, if what do we call it A again? What do you call it A?
Just the base.
Like the base. So if the base is the same,
You add your your base stays and you add your exponents. All right, let's turn to your packets. You have product of a power's property. Okay? So what I'm going to do is I'm going to break this down step by step. I have 2 big numbers there, 5 and 2, right? I'm going to just multiply those together because that's what my sign tells me to do. I'm multiplying. What's 5 times 2? 10. Okay? Then I have Q and Q. We have to remember back to day 1, if there is not a power here, I assume my power is what? No, that's my root, 1. I assume my power is 1. Okay, so I have Q to the first times Q to the fourth. I'm going to add those exponents. What will it become? Q to the 5th. This only gets tricky if you go too fast and like you multiply your exponents. That's the most common mistake. So just take your time. In this case, no. But we have 6 different categories here. All right, so then I have my R. We have R to the 3rd that we're multiplying times R to the 3rd. I have the same base, so that stays R. What's my new exponent going to be? To the 6th. Good. And that is my answer. All right, let's look at.
What did you say about that you add?
Yes, so when we multiply the same base, we add our exponents. All right, we have the same thing here. We're multiplying.
Will our base be a negative number?
Yeah. So my base is going to be what? 17 times negative 3? Negative 21. Those are my numbers. Alright, and then I have a base of x cubed and x to the fifth. So I have x cubed times x to the fifth, which will become what? X to the eighth. Good. All good on product of a power? Okay. Now we're on power of a power. We're actually going to go below it. So the one right below, not going to the side. Power of a power. And make sure you're writing it in the right place. Alright, so the power of a power means I have an exponent and another exponent. Okay? That means I multiply them together. Okay, I multiply them together. So let's say that I have p squared to the power of 3. What that means is I'm going to multiply my exponents. So this would be p times 2 to the third. Sorry, p to the power of 2 times 3, which is what? P to the 6th. So power to a power, we multiply. Okay, if I had a fraction, say we had w to the power of 1/4 to the power of 2/3. Okay? Power to a power tells me that I'm going to multiply those numbers together. You can use your calculator if you want and then do math enter. What happens if you do that? Was 1/4 times 2/3? 1/6. You just have to be careful that you don't put like 1/4 to the power of 2/3. That's not what we're doing. Okay? When we see that these two numbers are together, then we need to multiply them together. Alright, let's look at our packet. Alright, do we see how we have power to a power here? We have 16 squared to the power of 1/4. Okay? In your calculators, type in what is 2 times 1/4? 1/2. Okay, we should have 16 to the power of 1/2.
That's all.
Wait, do you guys have a 2 there?
Yeah. You do get 1/2. You get 0.5, but then you're gonna do.
Okay, good. Alright, and then 16 to the power of 1/2 equals what? Anything to the power of 1/2 is really just the square root. Square root of 16 is 4.
What? Alright, hold up.
They're the same thing. Remember how we talked about power over root, right? I could type in 16, the power is 1, my root is 2. It's just the square root of 16. Just a little trick. You don't have to really know that.
Well, what if I got 8?
Did you put in parentheses your fraction?
Yeah.
16, raise it to 1 divided by 2?
16 times. Wait, divide or times?
No, you gotta see how it's an exponent, right?
Oh, yeah, that's.
So
I need to refer.
16,
Oh,
second,
okay.
Thank you, 7.
Thank you, Kevin. Kevin! That's what you were saying.
Alright, so you should get 4. Let's take a look at the next one. I want to multiply 1/6 and 2/5. So I have k to the power of 1/6 times 2/5. What do you guys get? What'd you get? 1 over 15. Good. All good on power over power? All right, power of a product. What I want you guys to do is I want you in the corner somewhere. This should be the one in the middle, top middle. I want you to write Oprah and put it in parentheses. Okay, so I'm going to show you guys why I call this Oprah. You may or may not know about this, but here we go. A long time ago, aka 2004, I was a freshman in high school.
You want a car?
No.
Okay.
But what she did was she was really the first person to do this, okay? She gave everyone in the audience a car.
What?
I will show you why this is significant.
Being given a special package, and I don't want you to open it. Do not open it. Cameras are on you, so do not open until I tell you. Joy rising. Joy is about to rise right now. Does everybody have a box? All right. Inside one of these boxes is a key. Do not open it yet. Okay, everybody listen up. Here is the deal. If your box has a key, you will be the last person today to get one of those cute little G6s. Okay? Who will it be? Are you ready? Hold on. Are you ready? JR is back in our audio booth. I want, JR, this calls for a drum roll. Cue the drum roll. All right, open your boxes. Open your boxes. 1, 2, 3.
She surprised them by giving everyone a car.
Joy rising! One of my all-time favorite, happiest
Pontiac.
moments ever. Everybody,
All right, I'll show you which car it was, guys, if you're dying to know.
Who was it? No, I knew it. I know. Rain cracks, right? Yeah.
So it was like this car.
Let them call like 12K. That's what.
Back then it was probably a little bit more expensive, but imagine that times like 400 people. Because she bought it for everybody in the audience.
No riding.
Okay.
No riding.
All right, so I show you that to tell you this. Okay? Whenever we see these parentheses, I want you to think about the O in Oprah, okay?
But do I see that in
Hold on. Hold on. This exponent on the outside goes to everything on the inside. So imagine Oprah's audience. You get a car, you get a car, you get a car. In our world of math, everything gets an exponent, okay? We are passing out exponents everywhere, okay? Ronaldo loves it. All right, here's your example. So let's say I have xy to the power of 4, okay? The reason why this is important in the whole you get a car thing is because everything has to get an exponent. If you forget that, the whole thing's wrong. All right? So x gets an exponent, y gets an exponent. And that's my answer. If you only do it to one thing, it's not right. All right? My second example is 5x squared to the power of 2. Okay? So you have to be careful because everything needs to get a 2. So what gets a 2 first?
5, 2.
Your 5 and then what?
X,
The x. Okay? So I have 5 that gets a 2. And then I have x that gets a 2. But do we see how this is power of a power? So what's 2 times 2? 4. We're almost done, not quite. I need to simplify. What's 5 squared?
5X.
What's 5 squared?
20.
Yeah, so 25, and then I just bring over my x to the 4. That is my answer. So we actually did 2 different rules in that one rule. Okay, we had to power to power, and then we had to distribute our exponent to everything. Any questions there? All right, grab your packets. All right, my car in this case is the 2. Everything is going to get a 2, my x and my y. Do we see how this is going to be power to a power? Okay, so I can go ahead and write x. My power on x is 4. So what do I do with 4 into 2? Nope, you don't add them. You multiply them. So what's 4 times 2? 8. And then we have y. What's 5 times 2? I don't have the same base. I can't combine those two. I have x and y.
But what if there was a 5 in front of the x, 8, and y?
Well, then it would go to the 5 as well. Alright, let's take a look at the next problem. Alright, this is what you're just asking, Ronaldo. My car is the 2. What all is going to get an exponent? What all gets an exponent here?
4, p, and q.
4, p, and q. What's 4 squared?
8.
Nope, that's the most common mistake. You guys multiply those. You only multiply the exponents.
4 squared.
4 squared is
Oh,
16. Okay. Then I have p to the power of 2 times 2. 4. And then what about q? 6. So we're now already adding in 2 different rules into one. Kind of. Well, it's not hard individually. It's like when you try to put everything together. That's when it gets confusing.
Wait, we gotta put, there's gonna be like 2 rules in one.
Yeah, sometimes this one has 2 rules. Power to a power, and then we had to distribute one exponent. Alright, negative exponent. Bottom middle. Alright, this is what I think of with the negative exponent. I want you guys to draw this house with a big E. It's the house of exponents. Alright, so let's say that you and your sibling, brother or sister who's younger, you're both hanging out upstairs. That's you. You're the first smiley face, okay? Hanging out upstairs. Your younger sibling is crying and is super annoying. Okay?
I know how to solve that.
What? Okay, no, we're not promoting violence here. Alright, so typically if this happens in the real world, your parents may say, alright, whoever's crying, like, separate them, right? They may move them somewhere else. Okay? Let's say that your crying brother here, or sister, has to go downstairs. When they go downstairs, they're happy again, life is easy, and now they're the ones. You can just put an X through, well, let's just draw. There we go. Alright, so, crying upstairs, move downstairs to get some space, the younger sibling's happy. Okay? The reason why I explain it like this is because when we have exponents that are negative, we do not like them. Okay? Like here, I have a negative exponent. I immediately want to draw a division symbol. Okay? If it's not already there, then I'm going to draw it. Here's your first example. Let's say I have x to the power of negative 2. All right, do I have a division sign here already? No, I can create one though. All right. Whatever is attached to the negative exponent has to move. Just like your sibling that was crying that moved downstairs, whatever is right next to that negative exponent has to go. So, what's attached to that negative 2?
X.
The x. So the x goes downstairs, and that exponent becomes opposite. It becomes happy again. Alright? Because this is a fraction, something has to be on top as a placeholder. What can I put there? Just 1. That is my answer. 1 over x squared. I don't like negative exponents.
There won't always be.
There won't always be 1.
That's all over here.
Alright, let's look at another one. Let's say I have negative 12x cubed. Alright? Listen guys. What is directly affected by the negative exponent? Just the x. That 12 is not direct, is not affected by it, okay? That negative exponent is attached to my x. Do I have a division sign already? No, let's draw one. Whatever's not affected stays on top. That 12 is unbothered. This x to the power of negative 3 needs to go downstairs. And that negative 3 becomes positive. So that is your answer. This concept gets difficult if you move too many things. So if you notice when I do this, I'm always circling what's right beside my negative exponent. All right, you got your packets? All right. You see that negative 1/2, right? It is right next to that 25. That 25 is a whole number. Okay? You don't just do the 5. You have to do the whole number. I don't already have a division symbol, so I'm going to plug one in. We can assume that this 25 to the power of negative 1 over 2 is already on top. I need to move it to the bottom. So when I move it to the bottom, we have 25 to the power of 1/2 on the bottom. What's on top? 1. Just 1 is a placeholder. Okay, when I move this to the bottom, because this is really like over 1, right? You just move this to the bottom. Some space here. And I'm left with the 25, positive 1/2, and the 1's on top. What is 25 to the power of 1/2? Which is also the square root of 25. 5. That is your answer. This will make more sense when we have variables, like the next one, I think. All right, on my next one, what is directly affected by negative 3?
X.
The x. And only the x. The 3 is not affected. I already have a division symbol, right? All right, so we're good. My 1 and my 3 can just stay where they are. They're not affected at all. What needs to move? This x to the power of negative 3 needs to move. I can move it to the top and it becomes what? X to the power of positive 3. Whenever we move it, we're moving it to make it positive. Okay? All right, we have quotient of powers. What does that word quotient mean?
Is it like adding?
Nope.
Answer?
Quotient is the answer of a division problem.
I just said answer, so I'm right.
You have it right. Okay? Answer of a division problem. What this means is that if I have two bases that are the same, and I have two exponents, I need to subtract my exponents. If we're dividing the same base, we subtract our exponents. And here's an example for you. Let's say I have x to the fifth divided by x to the second. Okay? Do I have the same base? Yes, and I want to divide, or sorry, I'll subtract. 5 minus 2 is x to the third. If we're dividing the same base, we subtract our exponents. The idea behind that is that if I have 5 x's on top, and I'm dividing by 2 x's, I can cancel out the ones that are equal. What's left over? X cubed on top.
What's the top part? Always go first.
The bigger number goes first. Well, I'll explain that in a second.
So if the 5 was on the bottom and the 2 was on the top, 5 would still come?
Yep, that's the way that I teach it, yes. I think it was easier for you guys. Alright, let's say that I have 5 to the 6th divided by 5 to the 2nd. Do I have the same base? Yes. What's 6 minus 2? 4. Type into your calculator, what's 5 to the 4th power? 5 to the 4th power.
25.
625. That's your answer. Of course, if you have this on your test, and you want to just type this into your calculator, like 5 to the power of 6 divided by 5 to the power of 2 and hit enter, it'll still give you 625 without all these process.
Oh, so once you do 6 minus 2 and then you gotta do 5 times 5.
5 to the power of 4, not 5 times 4 to the power. All right, great. Grab your packets. This one has a couple of rules in it, so let's break it down step by step. I have 25 divided by 20. Sorry, 20 divided by 25. Type that into your calculator. Math, enter, enter. What do you get?
20 divided by 25.
Yep. 4 over 5. Did everyone get that?
28.
0.8, but we don't want decimals. We need fractions. So always do math, enter, enter. If it doesn't reduce, it'll still give you 20 over 25. All right, then I have x to the 8th divided by x to the 3rd. What happens when I divide the same base? We subtract. So this becomes x to the 5th. All right, here's what I'm going to do. When I subtract exponent, when I divide my base and have to subtract exponents, I always do big from little. I do big from little, and I put my answer wherever the bigger number is, okay? So my answer is x to the 5th. Which number is higher, 8 or 3?
8.
8, so I put it on top. The reason I do it that way is because if not, you may end up with negative exponents, which is fine, but it makes you have an extra step of having to move that exponent. So we're trying to cut that out altogether. The perfect example is here. Y to the 2nd divided by y to the 5th. Well, let's do big over little. What's 5 minus 2? 3. Will that go on the top or the bottom? The bottom. If you did it always top first, that's fine, but you would get negative 3, and then you would have to move it down to the bottom, which is an extra step that you don't need. Does that make sense? This z is by itself. Where does it go? It just stays on top. It's not bothering anybody. This is my answer. Okay, does that one make sense? All right, pay attention for this one. I could clearly just go ahead and subtract big from little if I wanted to, but I don't want to. When I see negative exponents, I cringe. I want to get rid of them, okay? So let's do this step by step.
What's the date? 13?
Yes. My sister's birthday.
Happy birthday.
Hey, my brother.
Dude, on Friday,
Really?
the Punisher gets out, but
Nice. All right. Wait, I had your brother. Like 3 or 4 years ago. Damien?
Yeah.
Or Dor- Damien?
Dang, you still remember that?
All right, 3 over 9. 3 over 9. If I reduce that, what does it become?
1/3.
1/3. Okay. Here's what I'm going to do. I want to circle everything that has a negative exponent. Because I don't like it. I need to get rid of it. All right. This x to the power of -3, I'm going to move where? To the bottom. So let's move that down here, x to the 3rd. On the bottom, I have x to the power of -5. I'm going to move that to the top, so it can be positive. And then I'm going to move my y to the top, so that can be positive. Everything in red are my exponents that were negative that now are positive. What's left over that I need to write down? Y and z. They just stay up top because that's where they were. Okay? We're not done yet. That was just... Are you good, Ronaldo?
A little. Oh yeah, because the Y and Z is together. I see.
All right. So we already simplified our big numbers. That's 1/3. I have x to the 5th divided by x to the 3rd. What's 5 minus 3? 2. It goes on the top of the bottom. The bottom goes on the top. That 5 is bigger. So x squared goes on top. Okay, so I'm done with that one. Done with that one. Okay, here's a different rule. I am multiplying y cubed times y to the 1st. So I need to add them together. What's 3 plus 1?
4.
4. So far we've used like 4 different rules here. We had our negative exponents, we had division, we had multiplication. What's left over? Where does that z go? It just stays on, why? It's just regular z to the 1st power. It just stays on top. Okay, that was our 5th one, right? Okay. The last one is powers of quotient. Remember, when you see this parentheses and this exponent, I want you to think about okra. This one is also okra. It's just with division. Okay? Put your phone down.
Oh, yeah. Yeah, that's one.
Alright, so my example is if I have x over y to the power of 3. Okay? My car, or my exponent that we love, is 3, and everyone gets one. So the x gets a 3, the y gets a 3. So we have x to the 3rd over y to the 3rd. I just distributed that exponent because everything needs to get it. My second example, let's say I have 64 over 81 to the power of 1/2. Okay? That 64 is going to get a power of 1/2. And 81 is going to get a power of 1/2. Okay? Anything to the power of 1/2 is just saying, what's the square root of this? What's the square root of 64? 8. And the square root of 81? 9. This problem was on your homework, but you guys just did it all calculated, which is fine. You got a decimal, you hit math, enter, you got 8/9. But this is what we're doing. That 1/2 goes to everything. Does that make sense? All right, let's go back to our packet. All right, you can do this a couple of different ways. Some people like to simplify everything inside your parentheses first. So if you want to simplify this, I'm okay with that. I'm okay with you distributing that 2 first. Let's say we simplify this and we get, well, this 4 over 16 just becomes what? What's 4 over 16?
4 over 16 is 1.
1/4. All right, so we can have 1 over 4, and my exponent is 2. Okay. All I did was simplify my parentheses first. All right, so if everything gets an exponent, that means we're going to have r to the power of what?
Is that 1 in the R or?
It is a 1, but we don't have to really have that 1 there. Right, it'll be 6. Alright, so r to the 6th power. And then my 4 also gets a square. So what's 4 squared? 16. The longer way of doing that, I will show you. If we have 4r cubed divided by 16. I'm writing so big. So I got a question. Hold on. To the 2nd power. If you wanted to distribute this 2 to everything, it would go to the 4 and the r and the 16. You would get 4 squared times r to the 6th over 16 squared. Okay? Same problem, just a different, a different way. And then you could just do your math. 4 squared gives us 16, r to the 6th. 16 squared gives me 256. If you reduce that, you get 1 over 16. R to the 6th, which is the same answer that we got there. You don't need this 1 in front. It's understood.
So the number has, you know how it says R6 and then, no, R3, the lowest number is always on top, right?
What do you mean the lowest number is always on top?
Like for R3 and 4. I don't know which number. Never mind, I'm tweaking. Because I just saw that we got to divide 4 by 16. So, yeah, firstly,
Just divide it. Alright, let's see if the other one. This one, let's say that we want to. Let's go ahead and simplify whatever's in my parentheses first before I get my exponent involved. Someone type in, what's 343 divided by 27? Math, enter.
343
It just stays that way? Okay. So now that I know that that doesn't simplify, it's okay if you want to go ahead and distribute your negative. So that means everything gets a 1/3. My 343 gets 1/3, x gets 1/3, 27 gets 1/3, and y gets 1/3.
Did you say negative?
No.
Oh,
So we're going to have 343 to the power of 1/3. X to the 5th to the power of 1/3. But let's go ahead and simplify that. What's 5 times 1/3? 5/3. Let's multiply straight across. On the bottom, I'm going to have 27 to the power of 1/3. and y to the 9th to the power of 1/3. That's power to a power, so I multiply. What's 9 times 1/3? Just positive 3. Okay, you did the hard part. And your calculator was 343 to the power of 1/3. Okay, 7. This x to the power of 5/3 can stay because there's nothing else to combine it with. 27 to the power of 1/3 gives me what? 3. And my y cubed stays the same.
Yeah, go get a different water.
In a second.
One.
Alright, so that's all of our notes for today. If I were you, I'll put my name on this yellow sheet. That is your lifeline. Keep it in your binder. If you want to hole punch it, I'll give you the hole punch. What you are going to do, you see those 9 problems? Don't do number 5. We're going to do that together. But you have, let's see here. Let's say you have 15 minutes to do these 8 problems. And then we're going to go over them on the board. Okay?
Have you watched the yeah, that's what this
Yeah.
you know when you show up? Why
Alright guys, let's go ahead and finish this up.
I do the first one?
What'd you do?
What I get or what I get?
What did you do for that one? Because you can always do different things to get the answer.
Yeah. So look. Alright, so I got 2, right? This is called the basis 2.
So you kept your base 2?
Yes.
Okay, then what?
And then I added 1/4 plus 1/3.
Good. I did the same thing.
And I got 7/12. Then there's a 6.
Okay, so you got 7/12 to the power of 6. Alright, then what?
You have to do 6 times 7.
Yep, and then what'd you get?
7/2.
So then you had to do 2 to the, whoa. 2 to the power of 7/2?
Yeah,
And what'd you get?
that's what I got.
Put in your calculator. You should
So I
get,
think, what?
you should get 11.3 something. Did you guys get 11.3? Because we multiplied this. 7/12 times 6, you get 7/2. 7/12 comes from 1/4 plus 1/3. I told you you're supposed to get a decimal for this one.
Oh.
If you got 1/7 here, it's because you were not adding your fractions right. 1/4 plus 1/3 has to have the same denominator. Just use your calculator for all fractions. On number 2, did you guys move this y to the power of -2? Because that's what I would have done first. Did you do that? Alright, so on top you still have y or x. On the bottom you have x to the 4th and you have y, and we're bringing that other y down. Alright, so
That's the answer?
no, let's simplify it. We have the same base of x, 4 and 1, so I need to subtract. What's 4 minus 1?
3.
Will that go to the top or the bottom? The bottom, because that 4 is bigger. So that becomes x cubed. Then I have y to the 1st times y to the 2nd. If I multiply the same base, I add my exponent. So what's 1 plus 2? There's nothing on top. What can I put there?
What?
A 1.
You have to add it to your fraction.
If it starts a fraction, you have to have it keep a fraction. Unless everything on the bottom cancels out, and then you can get rid of that fraction. Alright, number 3, I also have an exponent here that I want to get rid of. Let me do this a little better. Okay, so I'm going to move it to the top. So I'm going to leave everything the same. That y to the 2nd goes to the top. Let's mark this between y to the second. On the bottom, we still have this plain x. Now we can simplify. What's 4 divided by 2? 2. X cubed divided by x to the first. Top or bottom? What? Top. That 3 is bigger. It goes to wherever the higher number is.
Oh, okay.
So that'll go on top. Then I have y to the first times y to the second. So we need to add our exponents. Y to the third. Now here, Carrie, I don't have anything on the bottom, right? So I don't have to put over 1 if I don't want to.
Oh, why is it y to the third?
Because we have to add these exponents, 1 plus 2.
Got it.
Let's look at number 4. Did you guys distribute this 2 to everything? So what's 4 squared?
8.
Nope.
16.
16, be careful. That's 4 squared. Okay. And when I have p to the power of 2 times 2. And then q to the power of 3 times 2. 6. This is what you should have for your answer. We skipped over number 5 because I don't have time to go over the 0 exponent, but I will next class. Number 6, you can do a couple of different ways, okay? If you, raise your hand if you just, or just say something, if you just distributed your 7 right away. Did anyone move that exponent first?
I moved the
Okay. Either way works. Let's say we have 2 to the 7th power, and then I have x to the power of, what's negative 4 times 7? Negative 28. All right. What is affected by that negative exponent? Just your x, right? So I need to create a fraction. What stays on top? What's 2 to the 7? Go ahead and type that in.
7, 14.
No, you're multiplying 2 times 7.
Oh, 7, 7.
What'd you get? You should get 128 on top. And then this guy moves to the bottom and becomes positive. X to the power of 28. Whenever we move that negative exponent, it becomes positive.
Now I got it.
Okay? Number 7, you could do this many different ways. But whenever you have all numbers, you can just put it in your calculators, right? I can have 64 to the power of 2/3 times 64 to the power of 2/3 and see what I get. If you break it down, my base is the same, right? What is 2/3 plus 2/3? 4/3. So in your calculator, if you do 64 to the power of 4/3, you should get 256. But if you wanted to, you could do parentheses 64 to the power of 2 divided by 3 times 64 to the power of 2 divided by 3. And you get 256.
Next time I'm doing that.
Whenever you have all numbers, you can always just type it straight in. Okay? Alright, for number 8, I'm going to move this x to the power of -1. I don't like that it is a negative exponent. So, we have x cubed on top. What else goes on top? This x to the first, right? Because I'm moving it. Is there anything left on the bottom?
No.
No. If you wanted to distribute your 4 first, that's fine. You can do that if you distribute your 4 first. So, my x gets an exponent of 4. My other x gets an exponent of 4. Okay, so this, what is x cubed times x to the first? you get x to the fourth, right? Are you guys with me?
Yeah.
I guess this probably confused you a little bit. Let's not do that yet. Sometimes I just like to do everything inside the parentheses first. So now, power to a power is going to be x to the 16. If you wanted to distribute your 4 first, that's fine. You will get x to the 12 divided by x to the negative 4th. And then you would have to move this to the top, which will still give you x to the 16th. Okay? Either way works. All right, the last one. All right, I can't do anything inside my parentheses yet, so I distribute my 1/3. What's negative 27 to the positive? Sorry, negative 27 to the power of 1/3. And then x times negative 3. Let's see, it's fine. Negative 9 to the power of 1/3 is negative 3. We just had to multiply those two. Do we understand what we're doing when we are multiplying negative 9 and 1/3? Okay, power to a power, we have to multiply. What do I not like about this problem right now? The negative exponent. Do I care about this negative number?
No.
I don't care about that, okay? That does not mean that we need to move anything. What's negative 27 to the power of 1/3? Negative 3. And I still have x to the power of negative 3. What needs to happen to this x to the power of negative 3?
Needs to go down.
It needs to move to the bottom. So I should have negative 3 over x to the 3rd. Bam.
And we're done.
And we're done.
I'm leaving.
I know that was a lot of work, guys. This stuff is hard. I get it. Turn to homework C so I can tell you what not to do.
We deserve donuts. We deserve donuts. I deserve a donut. I know.
All right, so whenever you have all numbers and it's telling you to evaluate, just type it into your calculator.
Where's the homework?
Homework C.
Said evaluate.
When it says rewrite the expression, that is your power over your root. Everyone write on your paper, P over R.
Where?
At the very top. Just write P over R.
For which one?
Just so it can remind you, power over root. Because 1 through 7, you need to be rewriting.
1 through 7.
When it says evaluate, that means to solve. Okay? You are not doing anything with a exponent of 0. We have not got there yet. That's kind of overload for you. So mark out number 15, not the whole thing. Just mark out the number. What number should do it?
Dang, what you gave us?
I know you gotta practice it.
15?
Exponents are hard.
Just number 15?
All right, good job, guys. You have 2 minutes to yourself.